Yes, turning on the microphone. Hi, everyone. Can anyone hear me? Okay, no, yeah? No, the microphone doesn't work. It does work. Nobody knows. Okay, let's continue. Thanks for coming. My name is Alon. I'm going to present a cool project I'm working on called SSV. Hopefully, we'll get your mind off the incredible heat we're all feeling. So, SSV stands for Secret Shared Validator. It's a decentralized infrastructure for Ethereum staking. Started out live as a research project by the Ethereum Foundation with the idea or the scope of taking an Ethereum validator and being able to split it into independent operators, and those operators kind of work and operate that validator. And we'll see why is that it's so important. But I think that kind of we need to take a step back and talk about Ethereum staking and where it's at and why it's so important. So Ethereum staking, December 2020 was the genesis for the Bitcoin chain. The Bitcoin chain is the POS chain for Ethereum. Currently 400,000 validators, $17,000 billion staked currently. Obviously, that was higher when Ethereum was higher. The big thing is in about 2 months, depending on who you're asking, there's going to be an event called The Merge. The Merge is basically this kind of single event that everyone has been working on the past few years, where we're going to eliminate or terminate the proof of work for Ethereum and move it into a proof of stake stage where all of the transaction on Ethereum will be processed and included in blocks via proof of stake. And that's a really, really big, obviously big change, right? So what it means for validators. Anyone is already staking on Ethereum? Directly or via like liquid staking protocols and stuff like that? Perfect. And so the good news for you guys is obviously you'll start getting transaction fees or priority fees and all of the above. That's a big, big change. Your validators will actually start processing transactions and including them into blocks. And that's basically the single point where everyone has been working for a while. But it also kind of puts emphasis on a lot of the different challenges in staking. So slashing, everyone knows what it is, right? You have a set of rules. If you break them, you get penalized. Slashing, it basically that. But it obviously gets more challenging as you actually processing transactions in the network. The way Ethereum staking is built currently, it does have a lot of issues with centralization because it's very difficult to develop and have a really, really robust infrastructure. So there's very few infrastructure providers, very few staking protocols, and it kind of tends to be centralized, and that's not good. And client diversity is kind of a subset of that problem, but in general, there's something called systemic risk on Ethereum, where the more you're being centralized in Ethereum, and specifically in proof of stake, it's very dangerous, much more than proof of work in some cases. There's an increasing and growing systemic risk on Ethereum itself, because the more it's centralized, the more there's single points of failure. If one of them gets compromised in any way, it can really hurt Ethereum. But it also, if you kind of go to the extreme scenario, in Ethereum, there's a proof of stake, there's a built-in mechanism where the more validators gets slashed in a single time frame, the higher are the penalties. And so you can think of, a very, very big staking operator getting compromised. That's a big, big hit into Ethereum for Ethereum. So all of those things are pretty challenging. All of those things need to be taken into consideration, especially as we move towards the merge and obviously post-merge. The bottom line is Ethereum staking is really hard. It's really hard for a number of reasons, but it also presents a lot of opportunities. This is basically how Ethereum staking infrastructure works today. It's very similar and very common between DIY stakers at home all the way to the big institutional ones. There's a bunch of validator keys. Those keys are private keys and public keys, which allows you to sign and earn rewards as a validator. You put them all into a piece of software called a validator client. That validator client needs to be connected to a Bitcoin node, and together they work, execute duties, get you rewarded. That's basically the infrastructure everyone is using. This infrastructure is very limited. So first of all, the key needs to be 24/7 online all the time. obviously because it needs to sign. You cannot run multiple copies of that key in multiple instances of a validator client for backup, for robustness, because you'll get slashed. It's very dangerous to do so. That's one of the reasons why it's so hard to build robust infrastructure. And all of the above really means that it's expensive and it's complicated to build infrastructure, which means there's very, very few operators that do so. And it literally goes against everything we've learned the past 30 years as software developers. You want to have robustness, you want to separate different duties, you want to make sure your infrastructure is backed up rightly in a way that makes sense. And with staking infrastructure, it gets very complicated and very challenging to do so. And that's where we fit in. And so those are kind of obviously I would say the ramifications of what it means. So centralization, hinders of innovation, and so on and so forth. And that's where we come in, SSV network. SSV stands for Secret Shared Validator. It's kind of the next gen infrastructure for staking on Ethereum. It works completely different than what I've just kind of explained. And the idea behind it is to be able to take an Ethereum validator, split it into independent operators, and that way achieve robustness, fault tolerance, decentralization, and so on and so forth. And so that's really kind of a big shift we're trying to push, and a big change in thinking, because going forward, we need those things. And it looks something like this. And so we still have validator keys, that's fine. But in the middle, something changed. Instead of having a single point of failure sits somewhere in your data center, all of a sudden you have a multiple of them. Each one of them is a completely independent node running somewhere by any completely independent operator in different states, in different countries, running on different data centers, different tech stacks, and so on and so forth. They work together via the SSV protocol. They coordinate, and they're able to sign duties for the validators, execute them, earn your rewards, and so on and so forth. The big benefit is, of course, that it's no longer centralized. If one of them fails, nothing happens. You can continue earning rewards. If one of them fails, your validator is not compromised anymore. That's a big change in the way validation works and infrastructure works. It uses two main technologies, threshold signatures and a BFT protocol, which basically means a consensus protocol. And together they achieve what I just explained. And for the kind of the more technical between you, this is kind of a very high level scheme of how it works. So a new duty for the validator comes in. A duty is kind of a responsibility the validator needs to do within the Bitcoin chain network. One of those nodes starts the duty, offers to the others something to sign on. They then go and decide on what to sign, if that something is valid, if that something is not slashable, et cetera, et cetera. And once they do that and decide what they want to sign, each one of them signs with their own key share, construct a signature, send it to the Bitcoin chain, and all is good, you're earning money. The big thing is by using a consensus protocol, we have fault tolerance. Fault tolerance means that if one or more of those nodes gets compromised, offline, maybe gets hacked, for whatever reason, the rest of them can continue working seamlessly. And that's a big improvement. So what is the kind of the real world benefit? So one is your validator key doesn't have to be, the full validator key doesn't have to be online anymore. That's a big advancement, right? So you have, from the current situation where the validator key has to be online 24/7, it's vulnerable, to a place where it doesn't have to be online, it can be secured in a cold storage, and it cannot be compromised as easily as before. Obviously, security is a big thing. If one of those nodes gets compromised, nothing happens. So you increase the likelihood of being compromised, reduce it significantly. You contribute to the decentralization of Ethereum. By decentralization, I mean that no single point of failure can harm or create risk, systemic risk on Ethereum. And the big thing, I think, for the developers between us is it's a reusable infrastructure. It means that if you want to develop a staking service, if you want to develop a staking protocol, you can use that as your infrastructure layer, and you don't need to reinvent the wheel every time you want to do something, which is a big, big thing for innovation. If you think about it, a lot of the innovation that happens, for example, with DeFi, happened because there were some fundamental building blocks that somebody developed, and they were able to be reused and reused and reused again in different protocols. And so by having a decentralized infrastructure for staking on Ethereum, being reusable, it's a very big step forward. And this whole thing is been running in testnet for 16 months. It has a bunch of validators and a bunch of operators running on it, 3,000 operators, close to 30,000 validators. It's been tested and retested and scaled and so on and so forth. And so it's not moon technology. It's something that really works. It's something that a lot of the leading staking infrastructure providers are already testing out. And so if you're a developer, you should definitely check it out. I wanted to give you kind of a glimpse of how it looks like in a very simplistic way, something you can go ahead and test right now after you leave this room. And obviously, I'll encourage you to do so. So you can go ahead and go into our web app, connect it to your MetaMask, and spin up a Praetor validator. It's very easy. Once you have the validator key, obviously, in a real-world situation, you might have that automatically generated, secured, and so on and so forth. But for the demo purposes or the testnet purposes, that works just fine. You can take your validator key, drop it into the web app. The web app, in the background, splits your key into shares. You select the operators, the permissionless, public, transparent operators on the network. You select who you want to work on your validator. Click a button, send a transaction into the blockchain, and all of a sudden, your validator now starts being worked on by those operators you chose. You can choose 4, 7, 10, 13, and so on. You don't have to use your key anymore. You can put it safely in the cold storage. Those operators, each one have a share. It doesn't have, none of them have the full key. So if one of them fails, 2 of them fail, nothing happens. And you can choose your operators by different configurations. You can say, I want each, on every continent, I want an operator. I want all of my operators to be US-based or Europe-based, but I want them to use different data centers. I want all of them to use not just different data centers, but different data center brands. I want each one of them to use different clients for their tech stack, and so on and so on and so forth. And so it really opens up a lot of opportunities. And you just run a validator without running a single line of script or a single line of code. And that's a big, big advancement forward. And so obviously, go and try it out. It's really, really cool how it works. And it's funny money. It doesn't cost you anything. And it opens up a huge variety of different use cases we want to promote. Not just the traditional staking pools, although this is obviously the leading kind of use case. But it opens up, and in my opinion, Ethereum staking is going to be everywhere. It opens up a lot of different use cases. And again, because it's a reusable infrastructure, it makes it that much more easy to develop and test things out. And so for me, the really kind of the big thing is, obviously after kind of introducing the tech, is to kind of appeal for developers to go and test it out. Because ultimately, I think that the future of Ethereum staking is in the use cases, in the variety of use cases we can generate as a community, the types of use cases that fits kind of different niches. And so if you're a developer, obviously check us out. But what we try to do is really incentivize and create acceleration innovation. And so we have dedicated grants for developers to come up with a great idea, get a grant, start working on something on SSV. And so it was just announced on CoinDesk. And so if you want to do that, somebody who wants to do that, please apply. We have a bunch of different companies already did so, started out with grants, starting building things on SSV. And we have the testnet v2 coming up, which is just literally the kind of the last mile before release candidate. We'll have an incentivized testnet built into that testnet as well. And so, yeah, if you have some time, if you're interested in Ethereum staking infrastructure, please check us out. And that's it. Thank you. Questions? Yeah.
With penalties on the network? Let's say one of the validator is down or something.
Yeah, so we really focus on being infrastructure. And so what we're hoping will happen is when a developer comes and builds, for example, a protocol or a staking service, they will choose their operators in fashion that really fits them. So it can be a permissionless, it could be whitelist kind of approach, it could be collateral based, whatever you choose. And all of those types of economical decisions will be made into their product. So we don't assume to kind of force you to choose or configure how you want to use SSV. We'll let you focus and do that. And we're focusing on being the best infrastructure. And so all of those type of application-specific decisions, like how do you choose your operators? How do you make sure they're not going rogue? And all of those decisions are really for the application layer, for the developer. And so you can use collateral, you can use whitelist solutions, and so on and so forth.
Sorry, maybe I misunderstood. So I can upload, like, say, my validator keys and pick a number of operators that will run my validator for me, right? Yeah, but what happens if, like, one of them or, like, say I pick 5 and then 3 of them go down?
Oh, you can choose. You can switch them over.
What about, like, slashing or penalties? What happens through SSV?
Again, SSV is not assuming how you choose your operators. If you choose the wrong operators, they could do harm, right? So the same way if you choose any other way of staking.
Okay, so then the penalties will just apply to my validators regardless. All it does is it just splits the key and allows it to
it enables you to use an infrastructure. Okay, how you use the infrastructure is really up to you.
Okay, thank you.
How does it work for splitting the fees between the operators and the key holders?
So each operator, that's actually a good question. We haven't put it in the presentation. So each operator sets its own fee. And it's an open market kind of approach. You can choose whatever operator you want, and you pay them exactly what they set up.
Another question is, if I already have a validator, can I switch to the SSV?
Yeah, so we basically have 2 types of key management. So you have a key management solution where you generate in some way your private key. It can be in a secure box or whatever you choose. And then you split the keys, give the shares to the operators. You can also have a more advanced type of key management, which is called DKG, distributed key management, or key generation, sorry, where the operators themselves, between themselves, you select a set of operators, between themselves, they generate a key, but none of them is actually holding the full key, neither do you. So each one of them still holds a share, but the full key is never assembled anywhere. Obviously, it's a more advanced type of key management. And so in that scenario, the key generation is actually the one also splitting the shares and giving them to the operators. Yeah.
So I'm wondering, what happens when you just strip the whole staking thing out of this use case and you just keep with the primitives of shared signing? What other use cases can you do in addition to just like staking?
Yeah, so if you generalize SSV, it's basically decide and sign. That's basically what it does. And so you can think of use cases like oracles, decentralized oracles, or even bridges. We haven't gotten there just yet. The only real limitation is the underlying key that you're using. So for example, ECDCA is a bit harder to do with MPC than BLS. But other than that, it's really any application which is decide and sign can be made use of SSV. So it's definitely something we're thinking of, but obviously we're focusing on Ethereum first. Yeah.
Are there scaling limitations to TSS and there's the size these validator sets can be?
So the validator sets, no. The operator sets, yeah. So in general, BFT is very expensive in terms of if you increase the number of operators you have. That's why, for example, Ethereum chose what it chose in terms of protocols, and Cosmos, for example, has, I think, 100 or something operators. So for our application, 4, 7, 10, and 13 is much more than what you need. You don't need a set of 50 operators to co-sign your validator. So practically for SSV, there is no limitation in terms of like use cases that can use it. But in general, BFT protocols don't like to be extended significantly in terms of the operator set. But for us, I think like 13 would be probably the maximum anyone will choose. So it's fine.
Thank you.
One question regarding the signing. How you prevent double signing? Or is this down to the operator?
That's a good question. So let me, you know what, let's make use of this slide. Yeah, so where BFT consensus is, part of the conditions for them to decide on to sign something, they need to pass validation, each one of the proposals to sign something. One of those steps is to check if it's slashable. And each one of those operators has an internal slashing database. And so they will never sign anything twice. It's kind of a distributed slashing database, if you will. Yeah.
Just to be sure to have understood correctly, so you don't actually have any hardware with you. You delegate that part to the operators, and you rely on them to actually manage the hardware and stuff like that.
Yeah, exactly. And the way you manage your operators is the interesting part. So you can have completely permissionless with collateral, something like Rocket Pool. Okay, or you have whitelisted type of operators, but you can still add more and more operators. You can have institutional staking where they have a very strict kind of KYC-based type of selection of operators and so on and so forth. I think that the important part here is that SSV in of itself, what it tries to do is take the single point of failure out of the equation for Ethereum. It doesn't mean that everyone can be an operator for everyone else. This is not what the protocol claims. What the protocol claims or tries to do is take single points of failure we have today, massive single points of failure. Like we have operators, taking providers that are holding, you know, tens of thousands of validators, and basically distribute that single point of failure. That will reduce significantly compromising those operators, compromises Ethereum. That's basically the big thing we're trying to do. Yeah.
How does the network latency look like? So let's say if as a validator I'm chose to be the proposer for the next block, how can you ensure that it's published for the next lot, and then similar for the attestation, actually, how can you ensure that it's broadcasted in time?
So we're seeing anywhere between 300 and 500 millisecond latency. And so if you take attestations, which is probably the most kind of sensitive to delays, you have about 4 seconds to broadcast an attestation to have it slotted into the next block. And so it's plenty room for any latency.
I'm curious, like, this redundancy that you've created can be used by home stakers. So if I want to run like multiple NUCs or like have a VPS or something to run a backup node, like obviously this would work for that, but you guys are building the infrastructure to enable this. So are there projects like tailoring to that where you can have like sort of turnkey DevOps solutions for your staking setup?
So we're actually working with Ethereum to kind of spin up an SSV node very, very quickly. I would say that if you're running one validator at home, that's probably like an overkill. But what you could do is maybe take 4 of your friends and run together a 32 ETH validator, and each one puts a quarter of the ETH. So that's definitely possible. Yeah.
And then another question I had was around like the random number generation for selecting the leaders, and like in your BFT protocol and all of that. Like, what do you use? Oh,
we're using round robin. Really simple. You don't need to have any randomness in selecting the operators, because the set of operators you choose already have the shares, right? So it's unlike Ethereum where you want to have randomness to prevent malicious actors. Yeah. The fault tolerance in our case is up to 1/3. So you usually choose 3F+1 operators. So up until 1F, you're safe in terms of malicious operators from your set. Over 1F, you could have compromised operators. Yeah. So if F is 1, you have 1. If F2, you have 2, and so on.
Maybe one last question.
Thank you, everyone.